You feel the weight before you understand what you're holding. Cool metal in your palm, that distinctive shine catching the light. A silver coin, a piece of jewelry, a circuit board contact. But here's what nobody thinks about. That silver didn't start as silver. It started as rock, buried miles underground, and someone had to rip it out of the earth and transform it. Everyone sees silver. We wear it. We use it in electronics and solar panels. But how the hell does a chunk of gray rock become the gleaming metal we recognize? You can't just pick up silver off the ground. It's hidden inside ore, chemically bonded to sulfur, lead, and copper. What actually happens between a mine shaft and a silver bar? The answer is controlled violence on a massive scale. Let's start with the obvious thing nobody notices. Humans have been extracting silver for 5,000 years, but they were doing it terribly. Ancient civilizations would heat silver-bearing ore and blow air over it, hoping impurities would burn away. Until the 1860s, when the Comstock lode in Nevada forced the invention of industrial refining, crushing, heating, and chemical extraction on an unprecedented scale. Today, we process ore that contains less than 0.01% silver and still make it profitable. Today, when you see a silver bar, you're looking at the end of a process that starts with explosives. Miners blast away tons of ore and crush it into powder finer than sand. Then comes flotation. They mix that powder with water and chemicals that make silver-bearing particles stick to air bubbles. The bubbles float to the surface carrying silver sulfide, while worthless rock sinks. It's a chemical trick happening in massive tanks, processing hundreds of tons per hour. But here comes the part nobody sees. That concentrated ore still isn't silver. It's silver sulfide mixed with lead and copper, so they roast it in giant furnaces at over 1,000 degrees Celsius, melting everything together. But it's still not pure. So they use electrolysis, submerging impure silver in a chemical bath and running electrical current through it. Pure silver atoms migrate to a cathode plate, while impurities fall away. It's filtering with electricity instead of a screen. The result? Refineries extract 99.99% pure silver from ore that started at 0.01%. That means processing 10,000 pounds of rock to get 1 pound of silver. A single large mine produces over 20 million ounces per year, enough to make 400 million coins. If you're finding this fascinating, hit that like button and subscribe to The Curious Mechanism for more hidden engineering stories. But you're probably thinking, what if the ore has gold too? The refinery isn't dumb. They use selective chemistry, dissolving everything in acid, then precipitating silver with salt, while gold stays dissolved. Or they pump chlorine gas through molten metal, which bonds with silver but not gold. The system targets specific metals based on temperature and chemistry. Now comes the invisible part. These refineries expect catastrophic failure. Furnaces at 1,200 degrees are lined with refractory bricks that withstand thermal shocks. Electrolysis tanks have titanium anodes that resist corrosion, and every step produces toxic waste. Slag, acid, arsenic, mercury, all separated and contained in concrete-lined ponds. The engineering you don't see is about not poisoning the environment while melting mountains. But here's an uncomfortable truth. Our modern world depends on silver flowing from these refineries. Silver is the most conductive metal on Earth. It's in every smartphone, every solar panel, every electrical switch. If silver mining stopped for 1 month, electronics manufacturing would collapse. We use over 1 billion ounces annually, yet most people never think about where it comes from. Silver isn't just a shiny metal. It's pulverized mountains, controlled explosions, and electrical precision combined to transform trace elements into pure conductivity. So next time you hold a silver coin or plug in your phone, pause. You're touching the end product of a process that crushes rock into powder, roasts it in furnaces, and filters it with electricity, all to extract atoms scattered through stone. You're holding industrial chemistry that most people think is simple, but is absurdly difficult. If this changed the way you see that silver ring on your finger, subscribe to The Curious Mechanism and hit the like button. Share this with someone who never thought about where metals actually come from. This is The Curious Mechanism, exploring the invisible systems that keep the world running.